Welcome students. Today we will start properties of definite integral. Watch the video very carefully and note it down these properties on fair notebook. Tomorrow in online class we will solve related problems.
Welcome to a lesson on the properties of the definite integral. In our first property, we have the integral of f of x from a to a equals 0. Notice in this case, the lower limit of integration and the upper limit of integration are the same, and therefore the interval of integration will have a width of 0, making this equal to 0. As an example, if we integrate this quadratic function from 2 to 2, again notice how the width of the interval is 0, and therefore the value of the def integral would be 0. Next we have the integral of f of x from a to b equals the opposite of the integral of f of x from b to a. So notice here we've changed the limits of integration. Here we're integrating from a to b, and here we're integrating from b to a. So if we change the order of integration, it'll change the sign of the definite integral. Again, as an example, if we integrate our quadratic function here from 0 to 4, because the function is non-negative over this closed interval, this would give us the area under the function and above the x-axis over this interval, which is this shaded region here, which is equal to 142 thirds. So notice how we're integrating from 0 to 4 in this direction. And now if we change the order of integration and integrate from 4 to 0, or in this direction, the outcome will be negative 142 thirds. Next, if k is a constant, the integral of k from a to b is equal to k times the quantity b minus a. So as an example, if we integrate 3 from 0 to 4, k is 3, so this is equal to 3 times b minus a would be 4 minus 0, giving us 3 times 4, which equals 12. And let's see why. If we graph the integrand function f of x equals 3, it would be this horizontal line here, and if our interval is from 0 to 4, notice how the area below the function and above the x-axis is this rectangle, and we know the area of a rectangle is length times width. So the value of k3 actually gives us the length of the rectangle, and b minus a, the width of the interval, gives us the width of the rectangle, which would be 4, giving us a result of 3 times 4, or 12, for the value of the def integral. Now here our constant function is non-negative, but it doesn't have to be for this to hold true. Next we have the integral of k times f of x from a to b equals k times the integral of f of x from a to b. So this is telling us that we can factor out the constant k, and it does not affect the value of the def integral. So as an example, if we have the integral of 2x from 0 to 2, we can factor out this 2 and write this as 2 times the integral of x from 0 to 2. In either case, the value of this def integral would be the area of this triangular region here. Again, because the function is non-negative over this closed interval. Next, we have the integral of f of x plus or minus g of x integrated from a to b is equal to the integral of f of x from a to b plus or minus the integral of g of x from a to b. So if we're integrating a sum or difference of functions, we can break it up into separate integrals if we wish. So as an example, if we're integrating this quadratic function from 0 to 4, because we have a sum or difference of 3 terms, we can write this as a sum or difference of 3 separate integrals, as we see here. Next we have the integral of f of x from a to b equals the integral of f of x from a to c plus the integral of f of x from c to b. To help visualize this, if we integrate sine x plus 3 from 0 to 3, again the function is non-negative over this closed interval, and therefore the shaded region would be the value of the def integral. And we can write this as 2 separate integrals. If we select, let's say, 2, if we integrate from 0 to 2, which would be this integral here, and then we add this integral where we integrate from 2 to 3, from here to here, the result would be the same as integrating from 0 to 3. Notice in this case, 2 is the value of c given in this property. In this case, 2 is in the closed interval from 0 to 3, but this property is still true even if c is not in the closed interval from a to b. Next, if f of x is less than or equal to g of x, then the integral of f of x from a to b will be less than or equal to the integral of g of x from a to b. As an example, this function here is f of x equals cosine x plus 1, and this function is g of x equals sine x plus 3. And since f of x is always less than or equal to g of x, the integral of cosine x plus 1 from 0 to 3 is less than or equal to the integral of sine x plus 3 from 0 to 3. Where because both functions are non-negative, this integral is equal to the area of this darker shaded region here, and this integral here would be equal to the area of the combined shaded regions we see here. Let's take a look at one more property. Here we're given the quantity b minus a times the minimum of function f on the closed interval from a to b is less than or equal to the integral of f of x from a to b, which is less than or equal to the quantity b minus a times the maximum of function f on the closed interval from a to b. Let's begin by looking at this middle graph here, where the function graphed is f of x equals sine x plus 3. So because the function is non-negative on this closed interval, this area is equal to the integral of sine x plus 3 from 0 to 3. And now if we select the minimum function value over this closed interval, it would be positive 3. So in green we have the graph of y equals 3, and the area below this function on the closed interval from 0 to 3 would be the quantity b minus a times this minimum function value, which in this case would be 3 times 3, or 9. And now the maximum function value of our function f of x is 4. So if we graphed y equals 4, which we see here in blue, and found the area under this function bounded by the x-axis, because it's a rectangle, we know it's going to be 4 times 3, giving us an area of 12. So this property is telling us the value of our definite integral, the integral of sine x plus 3, integrated from 0 to 3, must be greater than or equal to 9 and less than or equal to 12. And by using a non-negative function, we can easily see this is true by comparing the area under the functions. I hope you found this lesson helpful.